Recording.
Hi, this is Sai Varapalli. Today I'll be presenting you my understanding of solution for assignment 9. So in this assignment, we're gonna implement the reinforcement learning of policy TD based reinforcement learning for driving a car uphill the rock shown here, like by rocking back and forth. So this environment, first we're going to start by like loading all the libraries that we're going to need. So once we load all the libraries, we're going to load the mountain car environment that we're going to work on. So looking at this environment, so in this environment, there are basically three actions. So one would be the push left, making, pushing the car left and pushing the car right, or just don't push it. So, and then the observations would be, or like the feedback would be the position and the velocity. And the reward will be like, for every task performed, like we'll get the negative reward. So our model, or like our reinforcement learning model goal is to get as much low reward as possible. So to do that, we are going to import the environment. And then once we imported the environment, we're just going to look at like how the environment is. Okay, so we see the action, the observations, reward, done, and info. So as we see, like, the observations, like where the car is, and then the reward. If we perform any action, so we are just selecting a random action, so we perform the action, so our reward is going to be -1 for every action taken. And then done is false because the car didn't climb up. And then the info would be the observation, like how our environment is, like so as we can see the info here, the number of actions can be taken as 3, and then the limitations of the observations are, okay, our positional limit is -1.2 to 0.6, and then our velocity limit is -0.072 plus 0.07. So now what we're going to do is we want to discretize the positions and velocity in this case. So I'm specifying my number of positions and number of velocity as 20. So we're going to discretize that. We're going to get like 20 positions and 20 different velocities. So to do that, we implemented the namespace code here. And then once we discretized, as we could see, like we just printed out the so based upon the discrete values of positions and velocity, we are gonna also like see how many observations we could get and what would be the size of the Q table. So how many actions can be taken. So as we could see here, once we discretize the position and the velocity, these are the arrays that we got. And then now we're gonna specify the greedy action, and also convert the continuous value, like since your car will be going back and forth, it's a continuous value, so we're going to make our continuous value to fall in the discretized position, I mean like the discretized value that we got. And then we also going to implement the greedy action to take. So we're going to define those two functions. So as we could see here, we are implementing the make discrete. So from the observation, we get the position and the velocity, and then we're going to compare the position and velocity with the position, the discretized position space and the velocity space. And then we're going to get the pose bin, velocity bin. And then for the greedy action, let's say we have the Q table. So based upon the action, for every action, we're going to look at the Q value and see, okay, get the array, like, what are the values for each action. And then, okay, so based upon my Q value, whatever the action has the highest Q value, I'm going to select that action. So that's how we defined our greedy action here. So now for the exercise 1 here, we're going to implement the code to randomly select the action. Okay, so we're going to define the functions here. So define select function and the current exploration rate, what are the exploration rate is, and then the greedy action. And then first we're going to generate a random number using the random.random. And then once the random number is generated, we are going to compare it with the current exploration rate. If the random number generator is less than the current exploration rate, then we're gonna choose a random action from like we got 3 actions here, 0, 1, and 2. So we're just gonna select a random action from one of them, and then calculate the reward. So if not, if the random number generated is greater than or equal to the exploration rate, then we're gonna choose the greedy action. So from the greedy action, it's gonna see, okay, which action has the highest Q value, and then it's gonna pick that action. So by this, we're gonna get action by implementing this, we're gonna get the action to be taken. And then we are specifying our epsilon start at 100% over 1, and then the decay rate is 0.95, and epsilon minimum, so fall go minimum to like 0.05, and then stop it there. And then we are specifying our time steps or environmental episode steps as 1,000, and the episodes as 50,000, and then the learning rate as 0.1, and our gamma is 0.99. So once we set our required values here, then we're going to implement the off policy TD algorithm here. So in this, we're going to, so this is the implementation of the algorithm. So we're going to implement this function based upon the observations and the actions, and then the next coming, I mean, like future observations, and then the future action, and then the based upon the learning rate and the gamma. So as we could see here, so your current exploration will be the starting exploration. We are just starting that time to see how long it's going to take for the code to run. And then we're going to calculate the total reward character. So for time step, so initially we are just initializing the things here, resetting the environment. And okay, so based upon the greedy action, I mean, like based upon the Q table and the observation, we're gonna, you know, get the greedy action, or we're gonna get the action, and then based upon the action taken, we're gonna say, okay, if this action is taken, what will be your observation? So we're gonna look at the next observation. So and then update our Q table. So as we so this is the off policy TD algorithm that we implemented. So Q value of the current observation of the action will be equal to the current same Q value plus the learning rate of reward plus as you can say reward plus gamma of the next observation minus the current observation. So once we implemented our Q value, so this builds our Q value for each episode. And then we look at the time step, like, you know, we just update the time step for each time step, it goes on up, and then we sum up total reward to see what was the maximum reward that we got for the for each episode. So we're gonna print everything. So as we could see, like for each 100 episodes, we could see here, you know, our exploration rate was 1. Okay. So here the exploration rate was set to 0.9995. Okay. So okay. So our question was okay. So okay, instead of 0.95, our exploration rate was set to 0.995. So our model is gonna start with one exploration and then start reducing based upon the value we specified. So it's gonna decay slowly. So our exploration is going very slowly. So it's gonna go all the way down to our minimum exploration rate, which is 0.05, and stop it there. So once the model is trained, like, you know, once the model, once the model is, you know, run through all the episodes, it has this Q value table. So now we're just gonna look at the rewards, like how our rewards are for each episode. So as you can see, like for 50,000 episodes, these were our rewards. We just plotted the rewards that we got. And now using the virtual lift list. So now what we're gonna do is based upon the Q table that we got, like based upon the Q values, now we're gonna visually look at the function, or like visually look at the environment and implement the reinforcement learning on that environment based upon the Q values that we train, and see how our how the actions are taking place. So to do that, we're going to install the virtual display, and we're going to run all this code. And then once we're done here, we're going to again import the mountain car environment, and then we're gonna record the video. And once we're done, we're gonna just look at the video. So based upon the queue table that we generated, our actions are selected based upon those queue values. And once it's done, we're gonna get the environment here. So once I play this video, so this is what our model is trying to do. So our model is trying to move, make the car go back and forth and trying to reach up the hill. Here, since our exploration is very high, the model was always trying to explore more. So if we set our exploration to 0.95, so in this case, so initially the exploration started at 1, and then the decay rate was 0.95. So from 1, it decayed to subtracted 0.95, and it fall to 0.05 for the second run. And then that was our minimum, so it didn't go any further. So as we train here with that decay rate, so this was the reward that was generated. And then when we implemented the reaction taken by the reinforcement learning based upon the Q values, so this is how the model trained. So it in 4 seconds, like this is a 4-second video where our car was able to reach up the hill. So this is how we implement the off policy temporal difference algorithm on reinforcement learning algorithm to find the value function, best value function by approximating the value functions. So that's thank you.